In life, there's Roblox. Don't, don't let nothing stop you, because we ain't stopping.
Hello everyone. I am going to be showing you today how to make a moving platform that floats in Roblox. And a lot of the tutorials I've seen for this online that already exist, a lot of them are not showing how to make a floating platform, but more or less just a platform that scoots across the ground instead, which doesn't quite seem as spectacular if you ask me. And also a lot of them aren't very like precise or descriptive with like why we're doing what we're doing, and I personally like to learn like what the reasons are for us doing the things that we do when we're doing uh, you know any sort of game design or anything to do with programming, for example. So I'm going to try to my best to give some pretty good explanations as to why we're doing what we're doing in this video, and also try to make it as concise and efficient as I possibly can. So, without further ado, let's dive in. I've got just some basic geometry set up here for the level. I've just got two um, uh, blocks here and a spawn point on one side. And our goal today is going to be making a moving platform that will go between both of these pieces of level geometry here. And that will um, be a very good learning experience and also really satisfying whenever it's done, in my opinion. So let's get started. Um, since we're making a moving platform, I'd say the first thing we should go ahead and make is the platform itself. So in our workspace here, I'm just going to add a part, and I'm going to move it up here. I'm going to go ahead and get over here so I can make sure it's centered, because if it's not, it's going to bother me. Okay, so after we place the part, the first thing I'm going to do is just set the color to something more vibrant, so it's more appealing. And after that, I'm going to set its size to something a little bit bigger, because I don't think a 4 by 1 by 2 platform is going to be super easy to stand on, especially if there's more than one player. So let's just do an 8 by 1 by 8 for now. I think that looks good. There we go. Okay, so the next thing we're going to want to do is we're going to want to make um, two positions here, the start position and the end position. And those are going to be the positions that our platform is going to go back and forth moving between. I'm going to actually move the platform over here to the other end, and we can go ahead and add another part um, to our workspace. And this is going to be our end position, because the platform's starting on the right side here, and it's going to be moving over to the left side. And I'm actually going to go ahead and start renaming these parts while I'm at it. So I'm going to change the name of this one to platform, just to keep things organized. And I'm going to change the name of this one to end. And I personally think it's a good idea to set the size of your start and end parts to be the same size as your platform, just so that you can better visualize, where the platform is going to be sitting whenever it's stopped at either end. So I'm going to go ahead and set that to the same size as my platform is, which is 8 by 1 by 8. We're going to move it into place here. Same thing, same way as we did with the platform. And now that we've got that in place, I'm actually going to give it like a different color just so I can visualize this better. I'm just going to set it to red, because why not? And we've already got the name set to end. We want to make sure that this part is anchored so that it doesn't fall. And we want to make sure that the player does not collide with it. I'm going to actually duplicate this part now. And I'm going to do that with Control D. And I'm going to bring it the new one over here to where our current platform is sitting. I'm going to rename this one to start as opposed to end. We've already got all the variables set on it because I just duplicated it, so that's awesome. And now what we can do. I'm going to move the platform out of the way for just a moment so we can kind of see all three of our parts that we're working with here. We're going to want to, I guess, go ahead and group these things together because that will make them easier to work with and duplicate later on. So I'm just going to select all of them by left clicking, and then I can shift select the range of parts that I want here. And I'm just going to hit the group button up here, and that's going to place all three of those parts into their own model. And I'm actually just going to rename this model to moving platform just to be consistent and to make it make as much sense as possible. Now, what we're going to want to do is we're going to add some constraints to the platform. And these constraints are going to help us to make sure that the platform, first of all, doesn't rotate, and also make sure that the platform goes where we want it to go. So to do this, we're going to go to the platform, and I'm going to add three things to it. The first one is an align position node. The second one is an align orientation node. And then the third one is going to be an attachment. So once you have your two constraints and your attachment added to the platform, here's what we're going to do. This attachment is actually just a something that is required for the align position and align orientation constraints to function properly. And the way that it works is this. Let's take the align orientation node first here. So if I go in here, I'm going to set the mode, the alignment mode of the align orientation node to be one attachment. And what that's going to do is it's going to let us choose a single attachment to base our orientation off of. And that attachment is the one we currently have on the part. And by going into the attachment section under this attachment 0 and clicking in this empty box, it's going to give our cursor a slightly different shape, and that's just going to let us pick the attachment that we want to base the orientation on. So if I just click the attachment that we've got here that we added, that's going to set that for us. And so this align orientation node is going to make it so that our part, our platform, doesn't like, while it's moving around, make sure it doesn't like rotate wildly like this or anything. It's just going to keep the same orientation as it had whenever whenever the game starts. So that's done. Now the next thing we have to do is to set up our align position node. And with this one, we're also going to set its mode from 2 attachment to 1 attachment. And then under the attachments, attachment 0, we're going to click that, click our attachment like we did before. And you're going to notice when we do that, that a blue line is drawn from the center of our platform to this seemingly random spot in the world right here. And what that line represents is the align position constraint. It wants to make whatever it's attached to move to a specified position. And that position is specified by this position property here. And so you can think of this position property as kind of like a target for the align position constraint to follow. And it just so happens to be set to 0, 0, 0 by default, which makes sense because typically, 0, 0, 0 is just a default value. And that just happens to be right here. That's the center of our world right there. So we're going to have to actually update this in our code so that it doesn't try to move to that random spot whenever the game starts, but I'm kind of getting ahead of myself. We'll get to that in just a moment. So we have the 3 parts that we need right now set up. We've got the constraints set up for our platform. The last thing we need to do before we start diving into scripting is to set the velocity of our moving platform. And that the velocity is just, think of it as just like a top speed for the platform to be moving at. By default, in the align position node, this is where the velocity is defined. In the align position node, by default, the max velocity under the compliance section is set to infinity. So if we were to try to make the align position node move the platform somewhere, it's going to be virtually instant, as opposed to it appearing like a moving platform. So we need to change this to something more reasonable. And from my experience, 15 is a pretty good number, but you can play around with this and just see what works best for you in your particular game. And so that's actually all the configuring we need to do for our platform's constraints and all of the parts we need to place in the level. So now that we have this set up, what we're going to actually do now is start scripting. So in the moving platform model, I'm just going to add a script to it. Make sure it's uh, a script and not like a local script or a module script, because these are for different purposes. The local script only runs on client side, um, like it only runs for the client as opposed to on the server. And the module script, I don't actually know much about this one yet, but I know it's not what we need. So we're going to choose the script. And then in here, I'm going to zoom in. I'm going to erase everything that's in here. And let's think about this for a second. So first of all, what we need is a reference to our platform, as well as our start position and our end position. So I'm going to go ahead and put those in now. We do this by declaring a local variable. I'm going to call this one platform. And I'm going to set it equal to script dot parent. And what this is saying, script refers to the script file that we're in right now. So this script right here in the workspace. And then parent in this case refers to the node that is directly above the script, like the node that's at the next level above. So the parent is kind of the thing that holds the script, and in this case that means this moving platform model right here. So the parent of the script is the moving platform, the parent of the end part is the moving platform, and so on and so forth. The parent of the align position constraint is the platform, because that's the next level up. You can kind of see based on this indentation here how that hierarchy works. So we're going from the script to the parent, which is the moving platform, and then to reference our actual platform part, we can then go to platform, because that's what we named it. So again, we're going from the script to the parent, which is the moving platform model, and then to the platform part itself. That's how we get there. And the advantage of this is that it's going to let us reference these parts locally without having to worry about where they physically are in the workspace. Um, and that's huge for the ability to duplicate this moving platform and quickly build out a level with many moving platforms, because if we hard coded the position of the platform in the workspace, all of our code would break, and you would have to have separate names and everything for every single uh, part and component inside of each moving platform's model. And that's kind of the advantage to just reference things like this. So then we've got our reference to our platform. The next thing we need to get a reference to is our start position and our end position. So start position equals script dot parent dot start. And I actually just want the position uh, property from the start part. I don't want the actual like the entire part itself. I just want the position where it's sitting in the world. So I'm going to actually go ahead and just do dot position. That'll make things easier for us. Um, and then same thing on the end position. Local end position equals script dot parent dot end dot position. And so those are the three references that we need to be able to make this work. Okay, so now that we have our references to our parts in the world, the next thing we need to do is to make something that will allow our platform to go from the start position to the end position, and from the end position to the start position indefinitely, over and over and over forever. And the way we do that in programming is by using what's called a loop. And I'm going to write out the loop's structure here, and I will explain how that works. So in Lua, we have something called a while loop. And basically the structure of the while loop is we say while, and then in here there is a condition. And you can put any condition here that evaluates to true or false. And that could be checking a variable, it could be seeing where something is at in the world, or what have you. But we know for a fact we want this loop to run indefinitely. So the easiest way to make a while loop run forever is just to say while true, and that will make it run and never stop running until the program quits. And you might hear some people say that while true loops are bad, but they're not bad unless your code is messy or unpredictable. And everyone who programs anything will run into this problem eventually, and you will see what I mean whenever you do it the first time, because the program will lock up or the game will crash or whatever. But as long as you think about things the right way, or you can recognize what went wrong to cause the loop to run out of control and cause a crash, then you can account for that and use these loops properly. But anyway, I'm kind of digressing. So to continue, inside of this loop, like I said before, we want to do two things. We want to, if the platform is at the start position, we want it to move to the end position. If the platform is at the end position, we want it to move to the start position. And so I'm going to take that logic and I'm going to translate that into code here, and I'm going to explain a couple of things. So let's start with the first case. If platform dot position equals start position, then do something. So on the surface, this makes a lot of sense. We're saying if the platform's position is equal to the start position, then we want something to happen in here. We're going to run into a problem though, because the position property of the platform is what's called a vector 3. And vector 3s are that they're called that because they contain three different numbers. They contain an x position, a y position, and a z position, because we're working with 3D space, and the position represents somewhere in the 3D world. But these numbers aren't always whole numbers. They can have decimals, so it doesn't have to just be 1, 2, 3. It can be 1.5 or 1.25 or 1.00005. Um, and these things naturally occur whenever you're moving things around in 3D space using velocity and physics and stuff like that. So we have to account for that. So there is a way for us to fix that problem to avoid the issues with the positions not being exactly the same exact position. And that is a function on the Roblox Vector 3 documentation page, which I will show you now. I've already got it pulled up here, so I can just go back to it. But on this page, this describes like all of the properties and methods that are available to us as part of the Vector 3 class in Roblox. And if we scroll down a little bit, we're going to see this function here called fuzzy EQ. It stands for fuzzy equal um, or fuzzy equality. It just depends on how you want to think about it. And what that function is going to do for us, we can call it from a vector 3, which is what this position is right here. We can call it from that, and we give it another vector and also this thing called an epsilon. And the epsilon is our margin of error that we're going to be working with. So I will show you how this works, and if you have any questions, feel free to let me know about it. I'm going to erase this part of our if statement right here. So what we're going to do is we're going to say platform.position fuzzy equals, and then we need to give it a vector 3. So the start position and end position that we have here are both vector 3s, and that's what we want to compare against. So if the platform.position fuzzy equals the start position in this case, comma, and then we need to give it our epsilon or our margin of error. So the margin of error that I found to work the best through just some experimentation was 0.05. And there are definitely other numbers that will work here. This isn't like something that's set in stone, but this was very accurate, and it worked very well for me whenever I was testing this the other night when I was originally making this. So we're going to stick with that. So if platform.position fuzzy equals the start position plus or minus our margin of error, like basically as long as this position is within 0.05 units from the start position, we're going to say they're equal for all intents and purposes. And that's kind of the benefit of this function, is it makes it so that we don't have to worry about positions being precisely equal, for us to be able to do what we want to do. And so in the if statement, I'm actually going to go ahead and make another condition here. So we'll say else if, and then here we're going to compare against the in position. So else if platform dot position fuzzy equals the in position with our margin of error, then we're going to do something between these two blocks. And so the first thing I would like to point out here with this code is that we have our margin of error here, and it's written twice. And whenever you have random numbers like this just plugged into your code, in programming, these are called magic numbers. And magic numbers can be an absolute pain to deal with if you're not careful with them. The best thing we can do to prevent problems with magic numbers is to, instead of just plugging them in like this, give them clear and concise variable names that clearly state what they are. So instead of leaving these plugged in here, what I'm going to do is I'm going to go up here between uh, our part references and our loop, and I'm going to put some more variables here. So I'm going to make another variable. I'm going to call it, in this case, margin of error. And we could call this like epsilon because that's technically what it's referred to as in the documentation. But I doubt that a lot of people would know what the word epsilon means just looking at it. I think margin of error is a much more like, oh, okay, that makes sense kind of variable name, and that's kind of the way you want to think about naming variables. Um, they're uh, if a variable's name tells you clearly what it does or like what its purpose is, it's a good variable name. Um, so I'm going to just take our margin of error, which is 0.05, and just put it in that variable and store it there. So what this lets me do now is I can take this variable and I can substitute these magic numbers in our code for that variable name. So if I ever decide I want to change the margin of error, not only am I um, not having to change it in two places, but I also have the convenience of it just being right here at the top of the code for me to just change to, whatever I want it to be. Um, and it's very clear whenever somebody's reading this, they can clearly say, if the platform's position fuzzy equals the start position with our margin of error, like that makes complete sense to me, looking at that, without having any context. Like it's just everything is named in a really good way. It makes sense, and it will, you'll thank yourself later on if you come back to the code and you work on it again after not looking at it for a while, because things will still make sense as opposed to if you just had random numbers and variable names that weren't very descriptive plugged in. Okay, so enough talk about magic numbers. The next thing we need to worry about here is we need to we know we now have the ability to check whether the platform is at the start or the end positions, but we haven't actually made it move yet. And the way we do that is we say, so if the platform is at the start position, we want to move it to the end position. And the way we do that is by referencing this align position constraint in the platform here. So we can just directly access that by saying platform dot align position. And that's just, like I said, going from the platform to the align position, very direct right there. Um, if so we say platform dot align position dot position equals the end position. Oops, end position. So what is this saying? We're going from we're taking our platform reference and we're saying get the align position constraint that's attached to this platform, which is right here. And if this was named something else, then we would have to type that name here, but it's called align position, so that's why we're saying align position. So we're saying go to the platform, find the align position constraint, and then set its target position to the end position. Because we're currently sitting at the start position, we want to go to the end position. And same thing down here. We're going to, this if statement says if we're at the end position, then we need to do something. So if we're at the end, we want to go to the start position. So same thing, platform dot align position dot position equals start position. And so this is pretty readable. We're saying if we're at the start position, move to the end position. if we're at the end position, move to the start position. Um, Now, realistically thinking about this, whenever the platform gets to the end, we want the players to have time to either get on the platform or get off of it before it starts moving again, because otherwise they're going to it's going to start moving right away. The players are going to accidentally walk off the edge and fall and die and be upset. You know, we don't want that. We want it to be pretty nice and to give them a little bit of leeway to get on or off the platform. To do that, I'm going to declare another variable up here, actually. I'm going to call this one um, platform. It's like, so this is going to be like an amount of time we're waiting for the platform to start moving again. So I think a good name for that would be platform wait time, and it's going to be in seconds. So I'll put that on here as well, so it's clear what the number is here. So platform wait time seconds, and then let's just say 5 seconds. So where we're going to plug that in is we're going to say if the platform is at the start position, we're going to wait for our specified amount of time, and then we're going to set it to move to the end position. So the way that I have found to do that is using this method called task.wait, and this will literally just halt the execution of our program here until the specified amount of time has passed. And you can see in the parentheses here, it's saying yields the current thread until the next heartbeat in which the given duration in seconds has passed. Which, there are some. It's a little wordy, but it's just saying wait this amount of time and then continue. So in there, I'm just going to put our platform wait time seconds variable that we made. Um, so we're saying if we're at the start position, we're going to wait for 5 seconds because we defined that right here. And then we're going to set the platform to move to the end position. Same thing down here. I'm going to uh, copy this and put it in our if block for the end position. So we're saying if the platform's position is equal to the end position, wait 5 seconds, and then have it move to the start position. And there is one final case here where we could run into, and that is if the platform is neither at the start position or the end position. In that case, um, we still need to make our program wait for a specified amount of time, because if we don't, that's when we run into the problem where the loop will just start running really, 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 really fast, and it will lag the game. It'll cause problems with the server, and it'll just be a really bad experience because it's taking up so much processing power. And so uh, we need to make it so this loop takes time before it does each of these checks. And the best way I've found to do that is to just put another task.wait outside of the if statement, and we're just going to have it set to a certain amount of time. And I think we'll make another variable for this, and we'll just call it script update delay, and that's also going to be in seconds. And then we'll just have it update every second. How about that? And so I'm going to put that variable that we just made inside of our task.wait right here. And that is going to allow our loop to not run as fast as possible and take up a lot of processing power, but it'll just run once every second. Like it'll go through, it'll be like, is the platform at the start position? Nope. Is the platform at the end position? Nope. Okay, wait 1 second. And then it's going to do that again. Is the platform at the start position? Nope. Is the platform at the end position? Nope. Wait 1 second. And eventually the platform will get to where it's going. Let's say it's going to the start position. It'll be like, if the platform is at the start position, yes, it is at the start position. Okay, make the platform wait 5 seconds, then set the platform to start moving again, and then it will exit the if block, and then it'll make the program wait another second before it updates again. Without this, like I said, the program will start running really fast when it's not at either of the start or the end positions, and it will cause a lot of server lag. But that's really all the code we need for this, other than one thing. And that one thing I'm referring to is that blue line that we were looking at earlier. This blue line denoting the initial target position of our aligned position constraint. is going to, when the game starts, it's going to try to make the platform move here. And we can look at that. We can see that if I just play the game, you'll see it start happening. And that's not something we want. We don't want it to move there. We want it to move between our start and end positions, and that be it. So we need to set this initial target position to something else so that it doesn't do that. And the best way that I've found to do that is to just set it equal to where the platform currently is when the game starts. So before we start our loop, I'm just going to go here below all of our variables and just say platform, or sorry, yeah, platform dot align position dot position equals platform dot position. And like I said, we're just saying the platform's align position constraint. We're setting its target position equal to the position the platform is already at. And this is legitimately all the code we'll need for this. Honestly, it's a lot cleaner than trying to use something like tweens for this particular type of purpose, in my opinion. Um, but yeah, I mean, let's just go ahead and give it a shot. I'm going to save this. I'm going to move the platform. And if you click this, it might actually select the whole model instead. So just make sure you click the platform in the Explorer here. I'm going to move the platform over to the in position where it's overlapping with the in sorry, the start position node. Um, that was weird. My mouse didn't want to let go of the. There we go. Okay, so that's in there now. And we can test the game and see what happens. So it should wait for 5 seconds and then start moving, which it is. It's coming over here. It has stopped. It's going to wait for 5 more seconds and then it should move again. And the player should go with it, which it does. And then same thing, wait 5 seconds and then it'll start moving back again, just following our logic that we gave it in the while loop. And so that's it. Essentially, you're done. The only thing we need to do now is to just make our start and end parts be transparent so that they're not there causing, any sort of annoyance with the visuals. So I've made those transparent, and the way I did that was I just selected both of them, and then under the appearance section here, you can just go to transparency and set that value to 1. Um, but if we play it now, you can see it'll just be like a normal moving platform in any other Roblox server. It'll wait 5 seconds at the start, come over, stop, wait 5 seconds, and then it will move back to the other end, and it'll just keep doing that until we close the server. If you have any questions, feel free to let me know, and I will be happy to try to answer them. Um, I'm still relatively new to the Roblox studio, so if I'm doing something abhorrently wrong, please feel free to let me know, and I will try to understand what I did wrong. But beyond that, I hope you have fun, and I hope that you found this helpful. And yeah, bye.